Okay, you're most welcome to this channel. Now we're going to look at Uneb Uce MTC item 2, number 2. It was brought, it came from the linear programming. So now I have this question which we want to go through slowly. Now I have a question. They're saying that a tailor makes school uniforms for boys and girls. A tailor makes school uniforms for boys and girls. Okay. The tailor makes at least 80. Now we shall be quoting out some of these words here. At least 80 sets of uniforms for boys, and not more than, let's underline this, and not more than 100 sets of uniforms for girls. Now also let's underline this. You see that we have the girls and boys. Less than that for girls, like that. Sets for boys. We're having that. Okay, now the thing. Each set of uniform for boys required 4 meters of material, and each set of uniform for girls required 3 meters of material. The tailor has at most, underline the word at most. The tailor has at most 600 meters of material to use. The tailor makes a profit. Now, whenever they reach this profit, this area is what we use to either maximize or minimize. Please, whenever you see this statement, just know you shouldn't report it as, or you shouldn't put it among the equations. So whenever you see a tailor makes a profit, the whole science has ended. It means that all the equations lie from here up, there, up. And let's go into that. You see that this part of profit will work here. In part B, we are saying that, or rather part C, help the tailor to determine the possible number of sets of boys and girls uniforms that should be made to maximize the profit. So it means that this profit stuff will be used in this part C. Right. So no problem. Now let's go on. Now this word, at least, the inequality we use for the word at least is greater than or equal. That's the inequality we use for at least. Then the one for not more than, if you say not more than 5, that means that not more than 5, it means that 5 and below. So therefore not more than 5 is the same as less than or equal. I'm putting that, I don't know if I can see them clearly, like that. Then also, I'm hinting out on the words I've underlined. They say that the tailor has at most. Now, the word at most also means less than or equal. This word at most means less than or equal. The words I've underlined. Now, I told you the profit stuff will only be used in part C, which part C can only be got when you have part B and A. All right, so the equations start from here. Upwards. Therefore, what you're going to do, we shall say that because they say that let the tailor makes a school uniform for boys and girls. Now let's say that let the girls, what should we take? Okay, let's start with let the boys school uniform be X. Then shall say let the girls school uniform be, let the girls school uniform be Y. Meaning that anything to do with girls shall use Y. Anything to do with boys, we shall use X. Okay, now let's start off. They are saying a tailor makes a school uniform for boys and girls. There is no number there, so I will not pick an equation there. The tailor makes at least 80 sets of uniforms for boys. The tailor makes at least 80 sets. So it means that the tailor makes at least, are you saying that? Makes at least 80. That's the meaning of the word at least. Greater than or equal to that 80. At least 80 sets of uniforms for boys. But boys we use what? Boys we are using X. Sorry for that. For boys we are using X. For boys are using x. Sorry for that disturbance. It was being just by the way. Okay, now here we say that they are saying that the tailor makes at least 80. The word at least 80 means greater than or equal to 80. Sets of uniforms for what? For boys. For boys, that means that for boys we use which letter? We use X, meaning that here for the boys, the uniforms they make for the boys is less than or equal, is greater than or equal to 80. The uniforms they make for boys is the uniforms they make for boys is greater than or equal to 80. That is it. And now that is our equation number 1. Proceeding, they are saying, and not more than 100 sets, and not more than 100. Not more than means this. 100. Not more than means that. Now, not more than 100, and not more than 100 sets of uniform for what? For girls. But for girls, they are using Y. So, Y. This means that the number of uniforms they make for girls is less than 100 meters. That is our equation number 2. All right, good. We are proceeding. They're saying each, take note of this, each set of uniform for boys, requires 4 meters. Each set of uniform for boys requires 4 meters of material. And take note of this word here. There's that word and each set of uniform for girls, each, take note of this word, each. Unlike this part, here we didn't have anything to do with each. That's why I wrote like that. But where you see each, it means that, you take the one for boys plus the one for girls. Then from there, you will go to the total. Whenever you see that word each, then that for boys plus girls, whenever you see the word each, because they said each set of uniform for boys required that. And each set, whenever you say each, meaning that you're going to add the meters for boys plus the meters for girls equal to the total. Now they say that each set of uniform for boys required. Now if they say each, what you're trying to mean is, like say for example, if one uniform you buy it at 200 shillings, like that. How about when they say each is at 200 shillings? How about when they are 4? To mean that to get the total here we say 4 times 200. Now same way here they're saying that each set, just one set of uniform for boys requires 4 meters. So that if one set requires 4 meters. Now you have to multiply it by the number of boys times, of course, here you see that here you said, for one uniform, if it is 200, for one boy, 200. What about when there are 4 boys? You multiply. So therefore here this will be for boys. But boys, you're using which letter? We are using X. So it is more like a 4 times X. 4 times X, if you can see that. Plus, now for girls, each set of, and each set of uniform for girls requires 3 meters. That means that a 3 times, how many girls are we having there? Y. We don't know the total. Like that. Now, what is remaining is the total. The total here, but in terms of inequality. Okay, let's proceed. Each set of uniform for that requires 3 meters of material. Full stop. Now, we don't have a total, but proceeding the same. The tailor has at most 600 meters. Now, the tailor has at most 600 meters. This is what the tailor is having in total. Because they have not specified, be careful, has at most 600 meters of material. They have not specified material for what? For girls, for boys. Where they have not specified, this means that this is the total for these people here. So that will be, but at most means what? Less than or equal. So this will be less than or equal to, I think 600. By the way, this needs only have covered this topic already. I know here some people will find it hard to understand, but soon or later we shall be studying this topic into full details, and that's when some of you will be able to understand the magic we're using here. All right, good. So there we are. Now next. Now what you must know is, maybe just to analyze the equations. The equations we have is, so we have now inequality. We have boundary line. Now inequality, boundary line must have equal sign on it. Then here maybe I'll talk about what? I'll talk about coordinates like that. Right. Maybe what I didn't talk about is, all right, maybe you can just go with that. Okay. Coordinates. All right, let's begin with this. The inequality is x less than or equal to 80. Now, the boundary line, to get a boundary line, you change this into an equal sign. That be now x is equal to 80. To get a boundary line, lines must have an equal sign. So you change this into an equal sign. They're like that. Okay. All right, so next we have y. Okay. Less than, oh, by the way, this was greater. This was greater. Regardless of whether it is greater or less, the sign, the what is here, an inequality changes the equal sign. So this is 100, and now this will be y is equal to 100, like that. Okay, finally, we're going to have this. Now here, it was a 4 times x. Why am I applying this? Because they said 4 for each, but the number of boys is x. We don't know. This x can be 10, can be 7. That's why I'm applying. So now that will be a 4, sorry, that will now be a 4x plus 3y less than or equal to 600. Now here, you shall need coordinates. Now, why you don't need coordinates here? Once it has one variable, or if it has only x, don't get coordinates. If it has only y, don't get coordinates. Not about when it has x and y. If it has a two variables or double variable, you have to get now the coordinates. So this will be now a 4x plus a 3y is equal to 600. Please, you just change this into an equal sign to get a boundary line. Now, to do that here, you shall need a coordinate. You shall need a coordinate there, and even here coordinate. Then from there, we shall go straight away and we plot. Now, about getting the coordinate, you must be steady on this level. About getting a coordinate, you can say, this is 4x plus 3y equals to 600. Please, we use equal sign to get coordinates. We want to say now, what if when we are using the intercept method, what if when x is 0? Then also the other side, what if when y is 0? Like that. Now we come and substitute in. So x is 0, that will be now, x is 0, and you put here, this will be a 0. 4 times, okay, maybe 4 times 0 plus 3y equals to 600. So you see that here, 4 times 0 is 0 plus this. So just consider it as 3y is equal to 600 divided by 3, divided by 3. Like that. What will be your value of y? Now, mean that as you're letting x to be 0, my x here is 0, comma, that's the coordinate. Now we divide 600 divided by that will give you 200. So here also 200. Please remember, the coordinates are written in the form, x comma y. That's why when I said that x is equal to 0, I began with the x value first, comma, y is equal to 100, y value next. From there now, when y is equal to 0, we shall have that 4x plus 3 times 0 is equal to 600. Like that. So we're going to have now 4x is equal to 600 divided by 4, divided by 4. What will be our value of x? Let's try to reduce. By 2, shall get 2. By 2, shall get a 300. And of course, next by 2, 1. By 2, 150. So our value of x will also be 150, like that. But of course, coordinates start with x. So x is 150, so 150, comma, then y value, which is 0. That's what I'm having. I told you, please don't get coordinates for when it is just only x, only y. Don't get a coordinate, just leave it the way it is. We only get coordinates for when we have x and y in there. Then from there, this was saying that express the Taylor's conditions as inequalities and inclusions. Now, inequality is this, where we have these inequality signs. Inclusions are this, where we have boundary lines. So part A has been successfully answered. Now the coordinate part will be pushing us to what we call a feasible region. A feasible region is, like, say for example, if you have this, if you shade this side and you shade that side, then also this side. There's a small space which remains in the middle. We call it a feasible region. That's what this means, a feasible region. That's just a simple clarification. Okay, now what you must know, by default, these are also equations somewhere. Let me just put them here. By default, these equations must always be there on anything you do in linear programming. These equations I must. So you had equation 1, equation 2, equation 3, equation 3. Now, equation 4, x greater than or equal to 0 is equation 4. And y greater than or equal to 0 is equation 5. Please, any number of linear programming you do, these must always be there. They are there by default. You like it or not. And what it means is, if this tailor is making uniforms, it is very hard to find that tailor can either make, you can find that tailor has not made anything or something greater than that. That's what this means. X greater than or equal to 0. Please, by default, this is true. So if you get 3 equations from the question, these 2 are always a must. And maybe to write them in the table, they will be the same as x is equal to 0, and this one will be the same as y is equal to 0. And you all know that x equal to 0 is the same as the y-axis, and y equal to 0 is the same as the x-axis. I don't have enough space, that's why I'm putting them there, such that we can all see what's going on. Now look, see the coordinates we have. The coordinates we have is in 80, 100, 600, 200, the highest is 600. Or rather, no, we have 80, this, then here, 250. How shall we get there? The scale we can use in science, the scale can be 1 to 5, like that. If that fails, you go to 10, 20, 50. And as far as mathematics is concerned, we can use this one. So now, can a scale of 1 work? That is 1, 2, 3. Can a scale of 2 work? That is 2, 4, 6, 8. This cannot work. Can the scale of 5 work up to when you reach the 200? Very hard. Can the scale of 10 work? Be a bit hectic as per your graph paper if you try to figure out. 20 cannot work, but say that a 50 can easily work. So that will be, we can start from here. Now this is our y-axis, and this is our x-axis. So there are 4. Okay, if this is 0, I'll be skipping 1. This is now a 50. This is now a 100. This is now a 150. This is now a 200. This is now a 250. Because the highest value in the coordinates is 200. That's what I'm aiming at. All right. I can leave it at that. Now this side is 0. Okay, here we have 0. Here we have 50. 50. Here we have 100. Have 150. Have 200. 250. I've reached my highest value, 250, 300, like that. So it is very possible. Unlike when some teachers are teaching, they tend to always use 1, 2, 3, 4, 5 up to around 10. Please, we can have values which can go up to even 1,000, depending on which question they have brought at hand. Okay, good. Now, these are the values we're having. So now let's go about the plotting. Well, let's go about the plotting. Now, what you must know about the plotting, I've not put the title, but always on any graph, there must be a title. In simple terms, we shall put the title at the end, no problem. Now, what you must know is, I'll put it here. I don't have enough space. Whenever I have this, or this, or we have this, or this, if it has this and this, the lines will be dotted. If it has this and this, the lines will be solid like that. This is solid. Why? Once it has greater than, less than or equal, greater than or equal, like say for example, this is greater than or equal. Once it has that or equal, then it is solid. Or equal, solid. Without equal, it is dotted, meaning that our lines will be drawn straight as either dotted or solid. Solid means just a thick line like this. But then, let's see, from our work, this will be solid, solid, solid. So, like you are, the number they brought here required only solid lines. So you're a bit lucky. Don't forget, even these ones are solid. Okay, let's plot. You plot x is equal to 80, meaning that go to x-axis and look for 80. Go to x-axis and look for 80. Go to x-axis and look for 80. Oh, sorry, there's an error here we need to change. There's an error here we need to change in the naming of these scales. Right, so this is that. This is now the 100. This is now the 150. 50. This is now 200. 250. Then maybe you can put here 300, depending. Yeah, I think that is okay. I had skipped out one number and the scale wasn't proper. There must be an equal scale. I was skipping out one mark, because when you congest them, it will appear very small and even the visible region will be too small. That's why I have spaced them up. Okay. Now proceeding, what we're going to do, let's now start plotting. This means that on x-axis, going to look for 80. On x-axis, going to look for 80. On x-axis, going to look for 80. Or is it? On x-axis, down here is 50. We have 100. But what you should know is that midway, this is 0, 25, 50, 75. So 75, that means that the 80 is somewhere here. If I'm not mistaken, the 80 will be somewhere here, around this point. If I'm not mistaken, the 80 will be around there. So here it means that on x-axis, going to look for 80. On x-axis, going to look for 80. So this is my x-axis looking for 80. This is 50. From up here is 25. Of course, this is divided by 2. 25, 25. 25 plus 25 gives us 50. Meaning that every spacing, every 1 unit, every 1 centimeter has 25. So here 75. You just approximate the 80 will be somewhere here. So what you do, you can now get your ruler. Remember, here this will be a solid line. So therefore, you get your ruler. This will be reasonably here. You get your ruler. You get your ruler. Will be reasonably there. You get your ruler and draw. Get your ruler and draw that line. Get your ruler and draw that line. Allow me just make it go through such that we can or we can differentiate it, or you will allow me make it a bit thick so that you can see. But however, when you are plotting your graphs, you shouldn't make it thick like this, like that. So now therefore there you come and say x is equal to 80. Like that, x is equal to 80. Please, for you use a ruler, me I'm using a free hand because this is not even a squared paper. But I think with that you are able to at least understand. In the next lessons, you shall be using the graph papers themselves. Okay. Now from there, let's now go to this. At y, go on y-axis. Y is equal to 100 means that go on y-axis and look for 100. Y-axis equal to 100, it is here. So the line must move here. And it is a solid line. Why? It has the equal, less than or equal, greater than or equal, solid, less than or equal, solid. All right, so here we're going to have at 100, here we are. Allow me just make it a bit thick, such that you can put a difference and even make it go through like that. So this is now our y is equal to 100. Always name. And when you're naming, we use an equal sign, not inequality. Be careful. We don't use inequality. Once you use an inequality here, you lose the marks. All right, so we're having this. f(x), I'm done with this. I'm done with this. f(x) plus 3y is equal to 600 is one we want to plot, but its meaning is here. 0, 200, 50, 0. Let's plot this. 0, 200, 0 on x-axis. X-axis here, then 200 on y. We move up. It will be somewhere there. Please, I'm putting a big mark for you to be able to see. All right. Then 50 to 0. Now 50 on x-axis. 50 on x-axis, here we are. 50 on x-axis, here we are. Then 0. 50 to 0, it will be just there. Now what you do, get your ruler and draw a line through this and that. Now, if I try to, at least, if I try to bring it out, okay, if I try to bring it out, that's my line. It will go through via that and also like that. Well, it is a bit bent, but for you can use a ruler to get this done. You get your squared paper, and I've told you why I'm using a thick line is because I'm not having a squared paper. Yeah, but for the next lesson, I'll be using a squared paper. Now you come and name this. This has been 4x plus 3y equals to 600. That is the line. So we have plotted this. It is here. We have plotted this. It is here. Then we have plotted this, and it is there. Yeah, it is a line indeed. All right, good. So maybe I will need to make it go through like this, such that they can at least be in that format. Now from there, we need to also put, now I will not waste the time. This one here, y is same as x is equal to 0, same as y-axis. I have y-axis there, I will not waste time. Y is equal to 0, same as x-axis. I have x-axis is here. I will not waste time. Now let's go into the shading. Let's now go into the shading. And I think I'll use this area here. Just allow me clear that off. Let's go into the shading. Now, maybe I'll put here above the graph so that you can understand. Whenever you see this or that, you see that? Now here, wanted region, I will use WR to mean wanted region is wanted region is above. Wanted region is above. Or when you have that, it in simple terms means shade below. Means shade below. Then we have this has been greater than or equal or greater than. But if you have this less than or equal to, this means that shade above. Shade above. That's what it means. And I said we shall be having a full topic of linear programming, and that's when you shall come to understand some of those terminologies. But since we are revising, I will just give you a clue on it. However, we shall cover a full topic here. All right, now it means the shade above. Now let's go and make a follow-up. Let's make a follow-up. Let's start with this line. Y is equal to 0. Now which inequality was there? Maybe we can begin with this. Let's begin with this. Let's begin with this. Which inequality was associated with this x is equal to 80? X is equal to 80, the inequality is greater. Now greater, you see that when I have this line like this, okay, this is my line. Where is the greatest? From your number line, you see that the greatest is this side. The greatest is this side. Where is the greatest? Here I have x greater than or equal to 80. So that greatest in here like this. Where is the greatest? Greatest is this side. Just a moment. All right, sorry for the inconvenience. So now we are proceeding. I said that now, once you have this, like this, this is our line, this whole vertical part. You see that now, where is the greater? You see that if I'm doing like this on this line, this is my line. If I'm doing like this is my greater. So this is my greater. And realize that if this is my greater, this is now the wanted. It is the one we want. This side is the unwanted. The one which is obeying this. Now, if you look at this line, if I'm doing like this is my greater and this is my less. So therefore, if this is my greater, this is the wanted. So if this is the wanted, this is the unwanted. Therefore, I will shade this side. So I will get this line and I will have it shaded in that format. I will get that line and shade it in that format. You shade without fear, like that. Oh, by the way, This one. Oh, look, here we put it at 50. No. Remember here it was x is 150. Sorry. This meant to be 150, not 50. So we shall have to change this a little bit. Just a simple thing to change here. After all, it is a shaded part. Okay. Now here it's meant to be shaded at 150, so it's meant to be somewhere here. Sorry for that mistake. It's meant to be 150 at 0. So 150, then 0 units there, and then to plot this 150 and 0, so that will come this side, not at this 50. I had not seen this one at the very first start. Sorry for that mistake. Now we have to get this connected to this. So we're having this now. Sorry. Now, since I don't have a squared paper, you will allow me use these thick lines so that you can all see what this one is different from. Now, this is the line, the same as that. Okay, now we have shaded the other one. Now, let's come to this one. All right, which inequality are we having here? We have y is less than. Now, when you have this, look at this. I have this part on this line. I have here and here. Which one? Now, there is less than. Where is the less than? Less than is down. Less than is down. So that's what we want. The less than is down is what we want. So we don't want the one which is up. You shade. I told you the shading must be done without fear. Shade without fear. Like that. Remember, our line is here like this. You'll allow me to use thick lines. But in other examples, we shall use the squared paper. All right, good. Then, let's now go on. We have shaded this guy. Now, always, this x-axis and y-axis, whenever I meet x-axis, just shade it down. Never waste the time. X-axis, just shade it down. Whenever I meet y-axis, just shade this side. That's what we simply do. Don't waste time with these ones. X-axis, shade down. Y-axis, shade the other side, so that you don't affect this area. For x-axis and y-axis, that's how the shading is done. Let's now come to this. Now here, in between, we're having an inequality of less than or equal. Less than or equal, so therefore we have this line. Where is the less than? Less than is down. That's the wanted. Of course, the less than is down. This is below, this is above. So the less than is down is one we want. Now therefore I will shade the unwanted. Like that. Shaded above. And if you can look keenly, you see that if the shading continues really thick, you see that we have a feasible region in between here. We have this feasible region here. That small space which remains unshaded, we call it a feasible region. All right, good. Now, if that's our feasible region, I told you the title is required as far as the curriculum is concerned. All right, now, let's now go to this. They are saying that a tailor, the tailor makes a profit of shillings this on each set of boys. Now, whenever you see boys, just know X. And means a plus. So therefore, shall come and say, allow me rub away this part. Now, where they say that show the feasible region of the Taylor's condition on a Cartesian plane. This is a Cartesian plane, the XY plane, we sometimes call it a Cartesian plane. Now, I want to answer this part. Help the Taylor to determine the possible number of sets of boys and girls uniforms that should be made to maximize the profit. Maximize the profit, come and say now. I'm answering part C. So profit is equal to, now we come and pick this. 80,000 on each. Whenever you say on each, you have to multiply like I told you here, on each. So 8,000 on each set of what? Boys. So that means that to be 8,000 X and means the plus shillings. This on each means that this 6,000 must be multiplied by 6,000 on each set of girls' uniforms. So therefore, Y, like that. So to get a profit, we want to see, like from this feasible region, which pair can we pick that can give us the biggest or the maximum profits. Of course, in profits, they can't say that to minimize the profits. That doesn't carry sense in real life. Now, what you're going to do, always, what we do in simple terms, the simplest trick I'll give you here is to maximize, you always pick coordinates in the upper corner. Say for example, I'll take this coordinate here. Upper corner, what I'm meaning, this is a triangle like this. From here, this is the middle. This is now upper corner, this is lower corner. Upper corner, this is lower corner. So you can come and now pick a coordinate from, here and above. Me personally, I will take this. There are very many coordinates, but I'll just go straight away. Coordinate in the upper corner to maximize. To minimize, pick coordinates in the lower corner. So I'll pick this coordinate, and that coordinate is 100 on x and 50 on y. So that will be, the coordinate will be 100 on x and 50 on y. Please, the 100, this is my feasible region. The 100, I'm picking it from here. I'm picking a coordinate from here, upper corner. That is 100 on x, and the coordinate must be always in the format of x, y. So x value first as 100, then y value next. Of course, here that is a 50. Now what you do to get the maximum profits here, you come and say this 8,000 times, what's there for x? 100 plus 60,000 times, what's there for this? That is 550. And now this will be 800,000 plus 6 times 5, that is 30. That will give you 300,000. Now you add, which will be the maximum profit. And that will be 1,100,000 shillings. And that is the question already answered. Topic, linear programming. I'm really sorry, the space wasn't enough. That's why I had to make things congested. And also the graph, I used just a rough sketch of it because we didn't have a squared paper. But next time we shall have to get a squared paper. Thank you.